Hello guys, this is Prashant from MyLearnCube. In this lecture, we will start doing number systems. And as I've already told you that in this series and for number system also, we will try to solve and we will try to understand every topic with the help of some examples and previous year gate questions. So in number system, we have basically four types of number system in our syllabus. One is all famous decimal, another is binary, next one is octal, and another one is hexadecimal. So these are the four number systems we will cover in our syllabus. So suppose base is represented by r, so that in the decimal number system has base 10, binary has base 2, octal has base 8, and hexadecimal has base 16. So the possible digits, this is the rule of thumb, the possible digits or the possible number of digits for any number system ranges from 0 to r minus 1. That means for decimal the number of digits, permissible digits are 0 to 9. For binary 0, 1. For octal 0, 1 to 7, and for hexadecimal it is 0, 1 to 9. 10 is represented by A, 11 is represented by B, and up to 15 is represented by F. So this is 10, this is 11, and this is 15. So this is the basic metrics for your number system. Now such many questions, previous year questions are based on some conversions. So with this assumption that you know the basic parts of conversions, I will try to cover these conversions using some examples. So take one example. So before that, these number systems, all four number systems are sometimes called positional weight code. Positional weight code. Sorry, these are called positional weight code. So what do you mean by positional weight code? So you can take an example. Suppose this is 555 in base 10. So though all these three digits are same, but this digit has value 1 multiply 5. This digit has value 5 into 10, and this digit has value 5 into 100. That means though each digit has same face value, but their base value are different. This is unit digit, this is tens digit, this is 100 digits. That means each digit represent different weight, and that weight depends on its position. That's why they are called positional weight code. Now take an example. We'll see an example. Suppose I have a question in which I want to convert this F3, sorry, E. Suppose E in base 16 to base 2 binary. So for this question, I will first try to solve using traditional approach. So traditional approach, I will take a simple example. Suppose 6 and A. Suppose this is the traditional approach. Sorry, this is a question I am taking to solve with traditional approach. So this is, we have to first convert with base 10, and then base 10 by using long division method, by using long, make it simple, take it as a 3. By using long division method, we will convert into the required base 2. So this is the way, this is the traditional way to solve this question. That means 3 into 16 means converting this one, this conversion, 3 into 16 plus A, that means 48 plus 10, which is equivalent to 58. So this is the first conversion. Now the long division method is this one, 58 we have to create by 2. That means if you have any base here, suppose y, then you will replace this 2 by y. So for this 29, remainder 0, dividing 29 by 2, I think it will by 14, remainder 1, then 7, remainder 0, then 3, remainder 1, then 1, remainder 1, and then 1. I think this is the picture. So the output, final output is 1 1 1 0 1 0 base 2. So this is the traditional approach. But in gate, if you will solve by using this approach, so you may be successful to solve this question, but you are just lagging behind in terms of time. So the simple, I could say trick, not trick, the simple observation, you can say trick, but it's not necessary to mark a trick or tip, you can say. You can directly solve it. F3E, or in case of 3A, just represent A directly by 4-bit nibble. The 4-bit and 8-bit segment is called byte. The 4-bit segment is called nibble. So represent each of these digit, or each of this value just represent it by using a 4-bit nibble. So A represent 10, and 10 in binary is simple, you know, this one. 3, and 3 in binary you can represent this way. So directly you can put this is the answer. This is a simple way. So take this question now. The original question. The question was represent F3E base 16 into base 2. So traditional approach was base 16 to base 10 and then base 2. But in gate it will kill a lot of time. So the direct way is F3E. E represent 14. So 14 will be 8 for 12. This is your 14. Then this is your 3. And then this is your 15. And done. You are done. Hardly it will take 5 to 10 seconds. If you are in practice, it will take 5 to 10 seconds. Good. Now the next question. If you want to convert this same number base 16 into base 8, now how will you approach? So again, one approach was to base 16 to base 8, then using long division method to base 10, then base long division method to convert into base 8. Again, we can do directly. In case of hexadecimal, we represent each of these element using 4 bits. But in case of octal, we need only 3 bits. So how will you do? So first approach was this one. But the good approach is just convert this into first binary. And there is a simple way. E, you can write E represent here this way, 3 represent this way, and F will be represented by this way. Now this is your binary. Now converting from this binary to octal is very easy. Just take the group of 3 3 each. Just take a group of 3 3. So this represent what? Your 6. 4 plus 2 6. This group represent 7. This group represent 4, and this group again represent 7. Done. No need to convert from hexa to decimal and then to octal. There is a direct. This part you can solve in 3 seconds, and this part again you will be able to solve in 3 seconds. So in 6 seconds this question will be solved. So it is very easy. Now again, suppose if I want to convert this same question into decimal, so how will you do? Here you do not have any choice. You will just give the positional weight to each. Its position weight is 0, its position weight is 1, 2. So it will be F into 16 square plus 3 into 16 plus E into 16 to the power 0, which after solving will give you 3902 base 10. So this is the way to solve this. Now there is also a good question. The question is, how many digits, or not digits, in fact bits, how many bits are required to represent 7927 base 10 in binary. So one of the applicant or gate aspirant would approach, that means he will immediately start using long division method. This way it will give something, then it will give something, this, but it will definitely kill your 5 to 10 minutes, and there is a high chance of making error, making some error in this calculation. So there is a simple formula for this. There is a tricky formula for this. You can use that formula to direct compute 2 raised to the power n greater than equals to this number, whatever this number is. In this case it is 7927. So this is the formula you have to use. The least possible value of n which satisfy this relationship will be the answer. So in that case we know that 2 raised to power 10 is 1024, 2 raised to power 11 is 2048, 2 raised to power 12 is 4096, and 2 raised to power 13 is, just multiply to this, I think it will give 8192. So the least value of n which satisfy this equation for is 13. So the answer is 13. Done. No need to solve this matrix, this long division method. It will take a lot of time. Just use this formula, just write down on your notes and find out the value of n for which, find out the least value of n for which this equation holds. That value of n will be the answer. Okay. Now again, see this question again. There is a question 7927. If someone, instead of asking the number of bits, if someone asks you to convert this into binary, so again the conventional approach is okay, you are asking for binary, I will start this way to again then it will just start, means what, doing suppose x, it will give some 0 or 1, then again it will give y, it will in this way, but it will go again and again a long way. So first, time killing, and second, there is chance of error because the pressure at the time of gate is tremendous. So there is a lot of chance. For first, time killing, second, making error. So there is a way. If you see a smart way, there is a smart way to do this. Dividing this thing by 2 means it will take a long division. It will take a long. But dividing this same using 16, I think will serve our purpose. 16. It will give 495, 7, 16. I think 3, 0, F. Then again 16, 1, E. Then 16, 0, 1. I think this is equivalent to 1, E, F, 7 base 16. And this is very easy to convert into binary. 7 in binary is 0, 1, 1, 1. F, 1, 1, 1, 1. E, 1, 1, 1, 0. And 1 is 0, 0, 0, 1. Done. This is the answer. So now you can see, means if you keenly observe, in 1, 2, 3, 4 divisions I got the answer. But in this case, just try to solve a bit. 9, 2, 7. You have 2, 2, 3, just 2, 3, 6. 9, 6, 3. It will give 1. Now 2, 1, 9, 8, 1. Again 1. 2, 9, 9, 0. Again 1. 2, I think 4, 9, 5, 0, and going. So there is a time and also possibility of error. But this is the simple. You know that dividing it by 16 is done in 4 steps. And this is very easy part. You can convert binary to hexa and hexa to binary in seconds. So your smartness can save your time as well as effort. Good. Now the next question. Suppose if someone asks you this question, 2.3 base 4 plus 1.2 base 4 will give you the output in base 4. How will you approach? So before solving this question, you can see this thing. Suppose 9.3 or suppose 9.5 and 4.8. Let's suppose these are in base 10. Both are in base 10. So actually how we will perform? 5 plus 8, 13. Actually we do this like this. 13 divided by 10 gives quotient 1 and remainder 3. We put remainder here and quotient here. This quotient here. This is the actual approach how we do our addition or subtraction in case of decimal. Again 9 plus 1 10 plus 4 14. Again 14 10. Quotient is 1 and remainder is 4. Again 4 and the quotient. So this is the way we solve in case of decimal, and the same concept we need to follow in all base systems. Take this example. So 2.3 1.2, it is base 4 base 4. So 3 plus 2 is 5. I am just solving it for you. You can do it in mind also. So 4 1 4 1, remainder is 1 and quotient is 1. Again 4 2 plus 1 3 plus 1 4. 4 divided by 4, remainder will be 0, quotient will be 1. So this is the output. I think you can plug and play, means you can play with digits. Now you solve this for me. 5.8. Suppose it is base what? Base 9. Solve this. How? 8 plus 6, 14. 14 divided by 9 will give quotient 1, remainder 5. 5 plus 4, 9 plus 10. 10 divided by 9 will give what? Remainder 1, quotient 1. So this is the answer in case of base 9. I think you can solve such type of question now very easily. Now one more question. This is very important question. This question has been asked in GATE. So the question is, you have 58 base x and you want to represent the minimum possible, the minimum decimal value for 58 base x. Means this is the question representing this. So this is a very good question actually. You have 58 base x. So the minimum possible value the x can have is 9, because I have already told you if bases are, the possible digits or possible values are 0 1 to r minus 1. That means we cannot have base less than 9 for this number. So the least possible base, the least possible value for x we can have is 9. So since we have asked for minimum value, take that least possible base 9. Now convert this into decimal. It will give you 45 plus 8, which is nothing but 53 base 10. Done. This is the way how these type of questions are solved. So take one more example for this question. So 11c x base 10. I think now you will be able to solve this question. Okay, you are saying c is 12. So what is the least possible value of x you can have? 13. So 13 square into 1 plus 13 into 1 plus 13 to the power 0 into C. Solve this, you will give 169 plus 13 plus 12, which is nothing but 194 base 10. Done. Next question. Suppose this is the question. Now, but for what minimum base, or in fact for what base this equation will hold? For such type of question, I will show you the approach. Just suppose the base is R on both sides. Now solving, just convert both sides into decimal. So converting this into decimal will give 4 into R plus 1 is equal to 5 into R to the power 0. It will give you 4R plus 1. Oh, sorry. 4R plus 1 is equal to 5. And simply you can see that only at R is equal to 6 this equation hold. That means at R is equal to 6, you can say 24 plus 1 is equal to root 25, which is nothing but equals to 6. The answer is at R is equal to 6, this equation holds. So the answer is R is equal to 6. Okay. Next question. Do practice a lot question. Questions will give you first the variety of questions asked in gate. Also it gives you confidence. So at what base this equation holds? The fundament is just assume base R for all these. Solving this, 5R plus 1, 5R plus, sorry, R plus 1. 5R plus 1 is equal to 5 into, okay, this is 5. This is 5. 5R plus 1. So 5R plus 5 is equal to 5R plus 5. Now, from this equation, you can say that for any value of R, this equation hold. For R is equal to 1 also, 2 also, 3 also, 4 also, 5 also, 6 also, any. For any base R, this equation holds true. But these 5 options are not possible. Why? Why these options are not possible? Because here we are using digit 5, and we know that for any base R, the digits which are allowed is R minus 1, up to R minus 1. So the least possible R for which this equation hold is 6. That means this is good for all bases. The answer is this one. For all base greater than equals to 6, this equation holds true. The answer is this one. Great. Again, one more question. Now, suppose you have x square. This question is taken from Morris Meno, the book, the Bible, I think, for this subject is x square minus 11x plus 22 is equal to 0, and the root of this equation are also given. X is equal to 3, x is equal to 6, and you are asked about what is base of this equation, this number system. Okay, so one thing, for any equation, if these are the roots, x is equal to 3 and x is equal to 6 are roots, so definitely I can write this equation equivalent to this. This is simple mathematics. If these are the equation, then I can write this equation to this thing. Simple way. That means x square. So my approach is again to take, suppose the base is R. So we can solve this, convert this into decimal. R plus 1 into x, yes, R plus 1 into x plus 2r plus 2, this is base r, is equal to, I think this is x square minus 9x plus 18. Now solve this equation again. So x square minus r plus 1 into x plus 2r plus 2 is equal to x square minus 9x plus 18. Now solve this equation. Compare this equation. This r plus 1 representing this 9. Therefore, r plus 1 is equal to 9, which implies r is equal to 8. Hence, solved. Done. Now one more method for solving this equation. We have given x square minus 11x plus 22 is equal to 0, and we have given that x is equal to 3 and x is equal to 6 are the root of this equation. Okay. Now if it is so, then we can put, that means at x is equal to 3 we will have 9 minus, suppose this base is r, so we can write r plus 1 into 3. I just put at x is equal to 3 plus 2r plus 2. Very simple. What I am doing, I am just putting this x into this equation and taking the base r for this. So 9 minus 3r minus 3 plus 2r plus 2 is equal to 0, and I think solving this 9, 6, 8 minus r is equal to 0, r is equal to 8. So this is another method to solve this question. So the basic trick or the generalized trick for all such questions is, that means I'm just writing it in simple language, to determine the base. This is a simple trick statement. The base of an unknown system, convert these, actually we performed convert the unknown systems into decimal system. First convert the unknown system into decimal system first, and then solve for the value of base r. That's it. That means example is this one. What was here? I think in the previous example it was 5. So what we have did, we just first convert the unknown system into decimal system. Unknown, suppose unknown system is r, so first we have converted into 4r plus 1. This is decimal, and 5r. This is decimal. Okay. Now again just solve this equation, and we know that at r is equal to 6 this equation is solved. Hence answer. So first convert the unknown system into decimal system and then solve for the value of base r. Good. Now I am giving some questions, some practice question for you. 1 or 2 question only, not more than that. So there is very good question. You can try, and if you are not able to solve this question, just put your comment below the YouTube video. I will solve, or I will, or in fact we should discuss. We should make it a kind of discuss forum. And again on our Facebook page, we have Facebook page with the name of MyLearnCube. Also there is a group, Facebook group, GATE preparation by MyLearnCube. You can also use this as a platform, as a discussion platform. And in case of very urgent question, you can mail me directly on my mail ID gmail.com. But try to avoid using this, because if you have some question, try to post this question on this group or on the space, so that many of your friends can comment or can discuss among themselves. And if answer is not coming either here on YouTube comments, then you can directly mail to me on this email ID. And on the very rarest case, you can call me on my number, but after 5 p.m. But this is the rare of rarest case. This is the rare of rarest case. Okay. So there is a question. You will encourage to solve it. How many bits are required to represent 32 digits 32 digit decimal number? Just try to solve this question. It is really very good question. It has been asked in one of the PSU called EIL in 2030. So this is all for this lecture. Try to solve some good questions, some previous year gate question on number systems. In next lecture, hopefully we will cover some more on number systems, and also we will see some complement, means sign bit complementation, and some good concept of representation of signed binary numbers in your computer system. By then, thank you. Keep learning.